children, today we are going to start chapter 11, Mensuration. In this chapter we are going to learn all about area, perimeter, volume of plane figures as well as solid figures. Now I am sure that you people are familiar with area and perimeter. Some of you may or may not be familiar with volume, but in this chapter we will learn all about it. Here, mensuration is all about the measurement of area, perimeter and volume of the plane and solid figures. What are plane figures, children? Figures like circle, square, rectangle, trapezium, all of these are solid figures. Sorry, they are plane figures. And if we talk about solid figures, cone, sphere, cube, cuboid, all of these are solid shapes. So we are going to learn about area, perimeter and volume of all these figures and shapes. Here, first of all, what is area? The surface covered by the borderline of the figure is the area of the plane shape. For example, over here I have a square. This green part, this surface which is covered by this square is called its area. Unit of the area is square of the unit length. We always write the unit as unit square. For example, if the length is in meter, the unit of its area will be meter square. If the side of the square is in centimeter, so its area will be in centimeter square, right? Then what is perimeter? The perimeter is the length of the boundary of the plane shape. Now if I talk about perimeter, it is just the boundary. If I add all these sides, all the four sides, only the boundary, then it is called the perimeter. The unit of the perimeter is same as the unit length. For example, length of one side is in centimeter. So the perimeter will also be in centimeter. If the side is in meter, the perimeter will also be in meter. The green part is the area of the square and the distance all the way around the outside is the perimeter. So over here, let us repeat what is area. This green part, the surface which is covered by this square is the area. And what is the perimeter? This boundary is the perimeter. Here are some of the formulas that you will have to remember for various shapes. First of all, we have a square. If you want to find the area of a square, we already know what is the formula. It is side square, because all the sides of the square are going to be equal. So you can find the area of a square by the formula side square. If you want to find its perimeter, it is 4 into side. Rectangle, how do you find area of rectangle? Length into breadth, and the perimeter 2 into length plus breadth. Coming to triangle, area of triangle can be found using the formula half into base into height. And the perimeter will be the summation of all the three sides. Parallelogram, area will be base into height, perimeter will be 2 into the sum of adjacent sides. Area of a circle will be pi r square, and perimeter, which in the case of circle is called circumference, will be 2 pi r, where r is the radius of the circle. Coming to trapezium. A trapezium is a quadrilateral whose two sides are parallel, and if its non-parallel sides are equal, then it is said to be an isosceles trapezium. See, now we all know that trapezium is a quadrilateral. What is the meaning of quadrilateral? A shape, a figure which has four sides, that is a quadrilateral. Now if the quadrilateral has two opposite sides equal, a pair of opposite sides is equal and the another pair of opposite side is not equal, then it is called a trapezium. Here A and B, these are the parallel sides of the trapezium. Why are these not the parallel sides? Because for example, if I extend this like this, at some point they are going to meet, right? So they are not parallel, but here these two sides are parallel. So A and B are the parallel sides and H is the height of the trapezium. Now, how do we find the area of trapezium? Area of trapezium can be found by splitting this. See, now if you look at this carefully, here, this and this, these are the parallel sides of the trapezium. If you try to split this figure, you will get from here, if I am dividing this trapezium, I will get a rectangle and a triangle. So, in order to find the area of this full shape, what can I do is first I will find the area of rectangle, I will find the area of the triangle and I will add them. And as a result, I will get the area of the trapezium. Here, by splitting the figure, one way to find the area of trapezium is to divide it into 2 or 3 plane figures and then find the area. In the trapezium ABCD, we are talking about trapezium ABCD. It can be divided into 2 parts, that is a rectangle and a triangle. Area of ABCD will be area of ABED, here ABED. ABED, that is the rectangle, plus area of triangle DEC. So, when you use the formula, when you find the area of rectangle and the triangle and using the derivation when you try, you will get this formula. Area of trapezium will be 1 upon 2 A plus B into H. Now, what is A and B? Remember, recall, come on. A and B are the parallel sides of the trapezium. What is H? It is the perpendicular distance between these 2 parallel sides. So, this is the area of trapezium. You need to remember all these formulas, children. Now, what if it is a general quadrilateral? There is a formula which can be used for general quadrilaterals. To find the area of any quadrilateral, we can divide it into 2 triangles. And then the area can be easily calculated by calculating the area of both the triangles separately. For example, I have a quadrilateral over here. The name of the figure is not specified. It can be square, rectangle, parallelogram, whatever. Here we have ABCD. What I can do is I will divide this into 2 parts. If I draw this diagonal, it will form 2 triangles. Okay, so what I can do is I can find the area of this triangle, I can find the area of this triangle, and then I can add them. So, area of ABCD will be area of triangle ABC, here the first one, ABC, this is the first triangle, and area of triangle ACD, here ACD, this is the second triangle, and when you add them, you will get the area of quadrilateral. So, if you find for a triangle ABC, this is the height of the triangle. If you put it in the formula, what is the formula for area of triangle? Half into base into height. So, half into base over here will be AC, and what is the height? H1. Coming to the second triangle, half into AC. Again the AC will be base for triangle ACD. And what will be the height over here? It will be H2. So, the formula for the area of general quadrilateral will be half into H1 plus H2 into D. Now, where did this D come from? Look carefully. What is AC? AC is the diagonal. So, I can take half and AC in common. So, what will be left inside the bracket? H1 and H2. So, half into H1 plus H2 into D. What is D? D is the diagonal. Coming to area of rhombus. A rhombus is a quadrilateral with all sides equal and parallel, but not the right angle. Its 2 diagonals are perpendicular bisector to each other. In this also we can split the rhombus into 2 triangles and can find the area of rhombus easily. Again over here, you can divide this rhombus into 2 triangles and find the area. So, when you divide it into 2 triangles and try to find the area, you will get the area of rhombus to be half into D1 into D2. What are D1 and D2? They are the diagonals, 2 diagonals of the rhombus. So, these were all the basic formulas of area that you need to learn in this chapter. We will continue this chapter in our next lecture. Till then, bye bye.